Thank you. So can everyone hear me? We're good? They gave me a laser pointer, which is a terrible idea, but I can't point that high otherwise. So I've tweeted a link to the slides. My Twitter handle is Callahan. If you want to follow along, if you want to experiment instead of listening to me, feel free to go there. There's all sorts of information, other demos to look at, other resources. Check that out. Spoiler. All right, so I'm not talking about the new mobile web because we tried that once. We tried an old mobile web. We had WAP. We had WML. Who here remembers like Nokia feature phones with WAP? Okay, hey, I guess you come close to where Nokia is from, and you get people who remember that. That's great. The power of the web and the reason WAP failed and the reason the iPhone and things like that have succeeded is that the web is one platform. There's only one web. It's open, it's universal, it's decentralized. The same web is on my phone that is on my laptop. There's no single gatekeeper. There's no web store that I have to go to and convince someone to let me publish on the web. There are many domain providers, many hosting providers. I have many options, and this is the power of the web as a medium. It's a very, very low barrier to entry, very low friction, democratic medium. And I think that's important. So I work for Mozilla, and Mozilla works for the web. Mozilla is a nonprofit that, in its manifesto, states that the internet is a global public resource that must remain open and accessible. And a key to that is ensuring that there's a balance between private interest on the web and public interest on the web. The way that we work to ensure that balance is by building Firefox. Firefox is a completely free, open source web browser. You can hack on the code. We're rewriting our dev tools in React. So if you know React, you can make a huge contribution. Come talk to me later if you want to learn how to get involved. But we build Firefox so that when the world's largest corporations meet to determine what is going into the web platform, what the web is going to look like, that we have earned a place at that table as a peer and as a fellow implementer of the web, and that we can influence that and we can speak for the public good as someone that doesn't have a profit motive. I think that's really important. I think the web is a global resource. It's a public resource. It needs to be preserved. Feel free to talk to me about that afterwards. So part of the power of the web is its ubiquity. This is the Internet of Shit Twitter account talking about all of the failures in the IoT field. And it's being displayed on a Samsung smart fridge in a showroom at a home appliance store. The power of this is that that's mobile.twitter.com on that smart fridge. Samsung didn't have to go out to Twitter and say, hey, will you please implement Twitter for FridgeOS 1.0? And then they didn't have another company, say LG or someone else coming and say, but we have a better FridgeOS. Can you implement it for ours? No, they just implement the web. And they have access to all of the content that the web has. And so the web has this ability to shape itself into new forms that we hadn't imagined yet. But all of that content is there. It's hugely powerful. If you look closely, there are a couple things you can learn about this fridge. For one, it's using the Samsung built-in browser. It's not using Chrome or Firefox. That's custom UI. If you scroll down further, you can actually see it's running Android. But you also know that it has a web connection inside the showroom floor, which means if you buy the floor model of that fridge, you probably get access to Home Depot or Sears Wi-Fi network. So that's a pretty good deal. And we know that because if it didn't have a web connection and we tried to load mobile.twitter.com, we'd see something like this. The connection appears to be offline. Try again. So the web is ubiquitous, but the web isn't resilient. The Twitter app will never do this. You never open Twitter on your phone when you're on a train or on a flight and say, I'm sorry, just Twitter isn't available right now. No, you see what data it had the last time it was available, and you can still compose tweets. It'll just say, hey, I can't send this until I'm back online, or I can't retrieve new tweets until I'm back online. So apps have had this user experience and reliability win over the web. This talk is going to talk about how to fix that. Before we go on, I'm going to be showing a fair amount of code that uses some ES6 features. In particular, arrow functions. You can think of them as just a shorthand. If you look for that fat arrow there, on the left-hand side are the parameters, and on the right-hand side is the return value. So these two lines are equivalent. Take x, return x times 2. There's some nuances about how arrow functions are different from normal functions, but this is a JS conference. You can ask anyone else at your table. and someone will know. The second thing that you're going to see a lot of are promises. The signifier of promises are this .then method. Promises are an official ES6 codified way of handling asynchronicity in JavaScript. We used to have to nest callback inside callback inside callback inside callback, which worked, but it meant that the order of execution of our code wasn't a syntactic thing. It wasn't this statement, then this statement, then this statement. It was a side effect of the nesting of our code. Makes the code harder to reason about, makes things harder, errors harder to deal with. Promises let you just say, do this, .then, whenever that finishes, call this callback, then call this callback, and if any of them fail, pass the error to this handler. You'll see this a lot. Fetch, also, if you haven't seen it, promisey replacement for XML HTTP request. That's valid syntax. You say fetch, you give it a URL, you can optionally pass like method post. I'm a professional software developer. I cannot write an XHR request by hand. The syntax, can anyone in the room, do you remember the syntax well enough? All right, you, turn to someone at your table and prove it. Fetch, on the other hand, fetch data, you get a promise back, the promise eventually returns the data. Promises are everywhere. Now that we have a way to handle asynchronicity, you'll see them coming up in standards like fetch, service workers, push, background sync. The new ES 2017 async and await keywords are just syntactic sugar around promises. So you'll have to understand how these work. I really recommend investing the time to go through some blog articles, go through some experiments, figure these things out. So, back on track, reliability. How do service workers help us solve reliability? What's a service worker? Show of hands, who here knows what a service worker is? All right, who here has used them in production? Oh, okay, so maybe if you can write an XHR by hand and you've used service workers in production, I'll believe you on both of those counts. There are people doing this. It's available, it's in the release versions of Firefox and Chrome and Opera. Basically, service workers are like script tags, but for a whole domain instead of for an individual page. So when you open a new tab, the scripts on the page run, you close the tab, the scripts die. Service workers aren't quite like that. Service workers could be running without any tabs open at all, or you could have 10 tabs open, all sharing the same service worker. So it's a way to start providing an alternative to the page model of the web. Not a replacement for, an alternative, because there's some things that the page model just doesn't work for. Of course, service workers are going to have some superpowers if they can run without any tabs open, and if they're going to be able to do things like making the web work offline. So like any other powerful API, service workers require a secure connection. You have to have a TLS certificate. Show of hands, Let's Encrypt, have people heard of, used it? Okay, for those of you who haven't, Let's Encrypt is a joint venture between the Electronic Frontier Foundation and Mozilla to provide free TLS certificates that are trusted by every browser, that are usable for anything, private use, personal use, corporate use, for-profit, whatever. Security shouldn't be a choice between security and your wallet. So that's super great. This tip, if you remember nothing else, is worth at least 2,000 kroner, which, to put it in even further local terms, is about 4 Pilsa and a Coke. So, so you could either have a certificate, or you could have a certificate and some Pilsa. I know what I choose. So how do these work? You use a script tag to do kind of per-page JavaScript. For a service worker, you have to install the service worker file using JavaScript. So somewhere in a script tag, you check for support, so you do feature detection if service worker and navigator, then navigator service worker register, and you pass it the script to your JavaScript, or the path to your JavaScript file. You can also set the scope of the service worker. By default, it would just be the folder that the worker itself is in. And this kind of says, what page does my URL bar say, and what service worker gets to control that page? So by setting the scope to the root, any page on my domain could potentially be controlled by this service worker. You can have multiple service workers for your domain, only one will work at a time, and the most specific one is the one that's selected. One of the most immediate things you might want to do is preload a cache. We want to make the web work offline. There are things that you're going to want to have available. You're going to want your style sheets. You're going to want your basic app logic. A service worker, because it's running in a separate thread, and it's running independent of tabs, every API it uses is event-based and asynchronous. So when we do this install step, the service worker file will get downloaded, saved in the browser, and it'll start running. The browser will then give it an install event. So we can add an event listener for install and say, all right, Don't resolve this in. Like, wait until we open a cache and then add all these URLs to the cache. The caches API, you say caches.open and give it a name of a cache. If it doesn't exist, it gets created. And then you get a cache reference to that opened cache. And you can do things like add requests, go and synthesize requests, delete things. You can inspect the whole cache. The only things that ever appear in this cache are things that you put there. It's subject to normal browser quotas like you would see for IndexedDB or other things. If the browser ever needs more space, it'll start dropping from the least recently used cache entire caches at once. So you'll never have a situation where like half of your cache is missing. Either everything you put in there is there, or nothing is there. So we say, all right, on the install event, go and cache these things for us. They can be on other domains, they could be other resources, but we can say we want these files in the cache. And then the service worker, and this, oh, it's actually maybe legible. This screen is huge. If you're looking at the slides yourself, this is much more legible. The more important thing is just these graphics. The service worker can act as a proxy inside the user's browser that can intercept and modify requests. It can intercept and modify responses. So when a page goes and requests something like a style sheet, instead of going directly to the internet, first a fetch event will happen inside the service worker. The service worker could say, all right, well, I have that in my cache, so I can respond from the cache, and that request will never actually hit the network. And the code's pretty straightforward. You can say, all right, add an event listener for fetch, and then event respond with caches.match. So caches.match will search every cache in that domain. Look for that event's request. So that request object has the URL, the mode, the method, the headers. And then, if we get a response back, if the response is truthy, if we had a cache hit, return from the cache. Otherwise, go and fetch out to the network. Just resend that request. It looks a little bit like this. Started a page wants a file, it goes to the service worker says, wait, I'm going to check my cache. If that fails, I'll go to the network, and then I'll return that to the browser. You could also flip this and say, actually, I want to try to go to the network first, but if that fails, show the cache version. So you're preferring the up-to-date version and falling back to the cache. You could even build a hybrid that says, I want to immediately return the cache version, but in parallel, I want to go to the network and get an updated version for the next time. As an example, I've got a video here of something happening on a phone, but there's only one web, so we're going to do it on my desktop, on my normal browser instead. This is Pokédex.org, which I previously didn't understand anything about, but then Pokemon Go happened, and I can tell you all about it. So Nolan Lawson, the author of PouchDB, wrote this as a demo to show all sorts of techniques for making sites work well offline. One of the things you'll notice is that in the inspector, all of the style sheets, he's using CSS spriting, but it's just a normal link rel style sheet tag. And it's a normal script source JS main.js. From the perspective of this website, it has no idea that there's going to be a service worker between it and the internet. It has no idea it's behind a proxy. But if I turn my Wi-Fi off, watch the network tab, this isn't surprising. JavaScript can do this. But what if I refresh the page? Oh, it still worked. If we look over at the transferred, we can see that this is coming from a service worker instead of the network. And we can actually go into any of these and see the response headers. We can see the actual response. This looks to the browser just like a normal network request. All the headers are there, the body is there. It went out, and just instead of making it all the way to the internet, before it realized it didn't have a network connection, the service worker stepped in and said, wait, I have that in my cache, I'm going to return that. In Firefox, you can also go into the storage panel, look into cache storage, and see all of the files that are actually cached by this site. You can also go into IndexedDB and see all of the Pokemon data is stored in there. This whole site is open source. If you click on the About link, you get that. Super great resource to look at and learn. If we actually go into the worker, oh no, that broke. I'm using a nightly build with some weird settings. So I'll go into About debugging in Firefox, which will list all of the workers. And so I can start this worker up, I can debug it, And then in here, oh, right, it's all Babelified. Whatever. If we go into the repo, we'll do this later, or you can do this later on your own. You'll see that the code that Nolan's using literally is these 6 lines, where he's saying, look in the cache. If there's a response, return it. Otherwise, go to the network. So you can do this for real, and it makes a website that, I can close it. I can open it again. Pokédex.org. Just as if I was online, and I'm not. If I was in a browser that didn't support service workers like Safari, and I try to go to Pokédex.org, not connected to the internet. So this is an interesting property of service workers. The first time you hit the site, you don't have the service worker either, even if your browser supports it. So your site always has to work as if service workers weren't there. But if they are, you get a better experience when you come back. And when Apple finally decides to support service workers, Safari users will also get a better experience without you having to change any code. The nice thing about service workers is that it falls back to a traditional internet experience instead of being something that locks people out. You're not splitting the web into the service worker people and the people that don't. Let's turn Wi-Fi back on. Service workers also give you complete programmatic control over requests and responses. You don't just have to do simple caching. There's a link in the slides to this project, SW Delta, which will intercept requests and append the version you have. So if you ask for URL main.js and the version of your cache is 1.1.1, this will append a query parameter cache 1.1.1, and then it has a server-side implementation. It looks at the difference between the latest version and the cache version, creates a diff, ships the diff back, the service worker applies the diff to the cached version, puts that back in the cache, and then returns that. And so this is a way to kind of ship deltas and save a lot of bandwidth, save a lot of time for questionable increases or non-trivial increases in complexity. But it gives you an idea of the sorts of creative uses you could use this for. It's not just store this file as it is unmodified. The second big gap with web versus apps is engagement. Throughout the rest of the conference, think about how many times you take your phone out, turn on the screen, just glance at what notifications are there. Or how many times you pull your phone out of your pocket because it vibrated to tell you you had a notification. Apps can tell you when they're done with something. You don't have to go in and check. I don't have to go and see, has Drive finished uploading this file by switching to the tab or refreshing it. It'll tell me when it's done. And the web has had the ability to provide notifications, and they can show up just like any other native notification, but they've been limited to being on a single page, right? As long as you have the page open, it can give you a desktop notification. Slack does this. Service workers get you away from that page model. They give you a script that can run independent of the tabs. So you could actually have a service worker that, when it got an event, showed a notification, even if the tab wasn't open. So you could close your Gmail tab and still get notifications of new mail. In fact, Facebook is doing this in production. These are notifications, native notifications on Android coming from Facebook.com without the browser being open at all. Again, service workers are evented, so we'll use the push event for this. When we get a push event, we say, OK, show notification with a title and a body. Done. So we've looked at 3 events so far in service workers. Install, which is when you first get the service worker. Fetch, which is when a network request goes out, triggered by an image tag or a script tag or an XHR. Push, which is when the site wants to notify the browser somehow. There are many other events that exist or will be coming. Background sync is one that says, wake up the service worker and let it do some work when I come back online. There are proposals and ideas for things like geofencing. Wake up the service worker and let it run a callback when I enter a geographic area. Or wake it up at this time and date. The service worker story is much more generic and much more general purpose than the specific application of make it offline suggests. So where does this push event come from? Well, first, when you push, it'll look like a completely browser native, OS native notification. Right inside it, you can disable notifications. Because that can be annoying, of course, you have to give permission. The way you get permission is in your JavaScript on your page, you say navigator service worker ready. Then, once the service worker is ready, you can call push manager subscribe. And then, if the user clicks OK, you get a subscription object. That subscription object has all the metadata you need to show notifications on your users' computers. So what you'll want to do is you'll want to take that subscription object, turn it into JSON, post it to your backend somewhere and save it. Have a database row that says this user account has this subscription metadata. Mozilla has a website called the Service Worker Cookbook at the ever so clever serviceworke.rs domain that has annotated examples of all of this. For the push example, what you'll see is when you get that subscription back, inside is this enormously ridiculous URL at updates.push.services.mozilla.com. And if you post to that URL, and if the Wi-Fi works, there we go. Hello world. I get a notification. You see that the domain returned a 201 created, which lets me know that that message was successfully enqueued for delivery to the browser. You can do it again. And because these are native operating system messages, they show up in my notification drawer. You can dismiss them en masse. What the heck is happening here, and where did this URL come from? I learned GraphViz about an hour ago and built a graph for us instead of a whiteboard. What happens is the website does that get permission request. It says, I want to be able to show you service or show you notifications. The browser asks the user consents. The browser will go up to a third-party service operated by your browser manufacturer. So Chrome runs one of these, Mozilla runs one of these. It'll say, hey, I need a URL that I can give to a site to notify me. That's number 2. Push service will generate a random URL, send it back to the browser. The browser will generate some cryptographic keys client-side and pass the URL and the crypto keys in step 4 back to the website. That's where this massive string comes from. That's in the subscription object. Then when the website wants to communicate with the browser, it does it through this push service. So it sends a message to that service, and that service acts as a message queue because your laptop may be turned off, your phone may be in airplane mode. You'll notice that I sent the header TTL60. This says that I want this to be queued for a maximum of 60 seconds before it expires. So if the user comes online in the next 60 seconds, deliver the message. Otherwise, drop it. Of course, this is all open source. If you want to see how this works, our implementation is out there. The benefit to this architecture is it gives you a persistent location to queue messages compared to trying to talk to the browser directly. And it saves battery life because the browser can have a single WebSocket connected to this one service instead of an arbitrary number. So for instance, on Android, Firefox for Android actually uses, the push service will go and use Google Cloud Messaging because an Android phone will already have a connection to that service. So we kind of proxy to that. Again, everything in here is encrypted. We don't want access. We don't want to know anything about what metadata or what messages you're sending. We don't want to have that responsibility. We don't want to have that potential for privacy invasion. So without any message body, all this does is just wake up the push event and say, hey, I've got something. If you want to send a message body, you have to encrypt it to the keys that the browser passes to you at the same time it sends the URL. If we take this example again and we go back into about debugging, so you can see that all the service workers are asleep right now because they wake up, they handle their event, they go back to sleep. That's why we had those event wait until and event respond with functions or methods. They say like, wait until this is done until you turn the service worker off. Like, I'm not done yet. So I start this up and I hit debug. We can see the push event listener, show notification. Let's go ahead and set a breakpoint there. If I come over here, bing. Oh, whoops. Sorry, that's a different instance. All right, so I've got the breakpoint there. Let's say I'm offline. So normally, if I want to receive these push events, I would need to be connected to that service. But now that I'm offline, I don't have that connection. Inside about debugging, I've got this push button, which will actually synthesize a push event client-side. So I can hit this. Wow, why isn't the debugger working? So this is what happens when you run a nightly build. This literally worked last week, but we have been splitting Firefox into multiple processes, and that sometimes causes issues. I will file a bug about that once we're gone, and I will tweet the link, and you can all follow it and be like, this messed up Dan on stage, please fix faster. Yeah. Oh, wait, no, I'm an idiot. Hang on, check this out. I have to set the breakpoint inside the body, because the function's already been registered, right? Or the listener's already been registered. So if I run this now, bing, it works. Another thing that's messed me up on stage is Apple will turn on Do Not Disturb mode when you connect to a projector. So I've been sitting here like, why aren't there any notifications? And they're all just piling up in the background. All right, so we've got this event. When we look at it, we can see it's a push event. We can pop this open. You know, see that there's no data associated with it, whatever. It's a debugger. You can step through it. Play with that on your own. The last thing, app manifests. These are how we solve installation. What do I mean by that? When we think about apps, native apps, you can install them, you can put them on your home screen, you can rearrange them, you can give them a place of prominence on your device. If I'm going to be using the bus schedule a lot, if I'm going to be using the weather website a lot, I want to have one-tap access to that. The web has historically, either you have bookmarks, which like get super ugly 16 by 16 images scaled up to be the size of whatever the launcher needs to be, or you have to go into your browser, then into the bookmark menu, then go past all the things that you swore you were going to read later and dig out the thing you wanted. It'd be way nicer if we could add stuff to the home screen. That's what manifests do. Manifests act kind of like head tags. They provide metadata, but for multi-page contexts, like web apps or larger sites. This is the production manifest, or most of it, for Flipkart, which is an Indian e-commerce retailer. In the head of their document, they'll say link rel manifest and point to this JSON file. Then they can provide a name, a short name, icons with various sizes and types. They can set the start URL to say the experience for this site begins on this page. Even if you're on some other page later and you want to interact with this as an app, it knows that that's the home, that's the initial starting location. You can launch or lock the orientation into a portrait. So when you launch the app, the phone turns the correct way. You can set display to standalone, which hides the URL bar and makes it look more like an appy experience. You can set a theme color, a background color. This display standalone thing is kind of interesting. This is a video of adding Flipkart-like to an Android home screen. So menu, add to home screen, add. If you go home, you can see the icon pops up. The name and icon are taken from the manifest. It looks just like a native app. When you tap it, you get a launch screen, just like a native app. And there's no browser Chrome. There's no URL bar, no back forward button. If you weren't a developer, if you hadn't seen that initial step, you would have no idea that this wasn't a native application. In fact, it very well could have been. I mean, the same exact technologies. You could be using Cordova or something and have built this already as a native app. It's just now you can get there from the web instead of proprietary paths. But that's also kind of weird because there's no URL bar and the web is the web. And how do you get back to it? The manifest spec is, I think, the weakest of this trio of service workers, push, and manifests. Because we don't know how to surface it. We don't know how to tell users that, like, hey, this app, or this website wants to act like an app. It wants to be on your home screen. It's capable of doing that. It knows how to work offline. And once you're in there, we don't really know how to say, actually, if you want to send somebody a link, here's how you get the URL. We've experimented with long pressing, but that conflicts with other things. Opera has recently experimented with a rather interesting option, so where you swipe down and then to the side, and that pops from the app experience into the browser experience. And then to get back, they have this little mobile phone badge by the URL bar. And so I don't know, clearly there's a need for this sort of stuff. There's a need to be able to say, here's my site's name, here's where it starts. It really only works in portrait mode, though if you're doing that, you maybe haven't learned the lesson that the web can show up on a fridge. But I don't know about this whole display standalone thing. Because is the web without URLs still the web at all? If you can't cut and paste, if you can't edit a URL, like what is that? So I don't know. But we need the rest of the metadata, and we'll figure it out. This is somewhere that you as developers, by adopting this, by experimenting with this, can actually provide a lot of meaningful input and shape the direction of the web. In the links on the slides repo on GitHub, there's a link to the Firefox bug. We've just now started preparing to implement display standalone in Firefox for Android. There are a lot of open questions. You can come in, you can actually say, well, I've been thinking about this, I've experimented with this. This doesn't work well, this does work well. So it's something that we have to learn how to get there together. Something that's been very humbling as a browser manufacturer is we're finally starting to realize that we don't know how to build websites. We know how to build web browsers, but like those are big C++ code bases that are compiled and shipped over the wire every couple of weeks or every couple of days for hot patches that don't resemble the web at all. We've had experiments like AppCache that totally failed. AppCache worked great if you used it exactly how we wanted you to use it to make the web work offline. But if you wanted to do something fancy like that patching the response in flight, or if you want to say, I want specifically these things cached as a fallback, not as the primary resource, we didn't have the tools for that. So the browser manufacturers have started trying to say, all right, let's give the developers, let's give you all in this room a set of tools, a toolbox. Instead of a specific tool, we'll give you a toolbox and we'll see what you do and we'll try to learn from that. It's the same way that jQuery influenced the document.querySelector method. There was a time when jQuery and Prototype and MooTools and all these other libraries competed on how fast they could parse CSS selectors to find DOM nodes. Because before those libraries, the way you selected DOM nodes was using an XML query language called XPath. Because browser manufacturers don't know how to make websites. But we can learn. And when we see these emergent properties, when we see people build things that make sense, then we can codify it. So that's kind of where we're starting with service workers. Here's a bunch of tools, or a toolbox. We'll see what tools come out of that. The important thing is that we try to work with the web. I've seen people light up at the suggestion that they can hide the URL bar. Like, oh, that's wonderful. I can finally disguise the fact that I'm using the web. I don't have to be ashamed that I'm using the web anymore. And I think that's not going to work long term. The web has a lot of quirks, but when we work with them, we get to a better place. So think about these tools as things that you can use to enhance your experience, not replace the web's experience. I'm going to be around all day tomorrow. Please come ask me more questions. Like I said, the slides are online. I tweeted the link. We also have two other Mozillians here sitting in the back, Flocky and Ender, who will be doing a free workshop on these technologies on Monday. Meetup.com/JavaScript Iceland. The registration will open tomorrow, just afternoon. And kudos to these folks who shared photos of the fridge and the Pilsa. So thank you so much. I have stickers up front, and keep rocking the free web.